Today we look at what happens when you really have a situation that's a no solution. And we're going to start talking about something called imaginary numbers. When I was a student, I always struggled with why do we even need imaginary numbers? If they don't even exist, why use them? So you just have to trust me that imaginary numbers are helpful. They come up a lot later in your life when you go to trigonometry or a lot of electricity and some other sciences. So even though it feels like there's weird to have such a thing as an imaginary number that's not real, we're still going to practice it so that your future life you can continue to use them. So imagine if you had the equation x squared plus 1 equal to 0. If we wanted to try to solve that, x squared plus 1 equals 0, we would minus 1 on both sides, get x squared equals negative 1. And to undo the squared, we would need to square root both sides of our equation, and we get the square root of negative 1. That's not possible. But now we're telling you it is. The square root of negative 1 is going to be the symbol called I. It stands for an imaginary number. In this case, it's imaginary 1. And you could put the 1 to show it's one imaginary number. And technically, most quadratics have two solutions because we always have a positive or a negative. So we could have positive I or negative I as our solution. I know it's weird, but just roll with me here for another example. So now if we have x squared plus 81 equals 0, we try to solve our equation by subtracting 81. X squared equals negative 81. And to get rid of the squared, we do the square root of negative 81. Well, I can't in real life square root negative 81, but I can in imaginary land, and I end up with an imaginary number. And then we just think about the regular square root of 81. The square root of 81 is 9. So instead of saying our answer is 9, we say it's imaginary 9, or 9i. And don't forget, you could have two separate answers, positive imaginary 9 or negative imaginary 9. And if you prefer, you can write them separately. 9i and negative 9i. Let's see about how we can use this farther. So now we have a little bit more complex equation to solve. Anytime you have an equation that has a squared, you need to use quadratic formula or factoring or complete the square. Because we're practicing imaginary numbers, I'm not going to use factoring, I'll use quadratic formula. We have to first make the equation equal to 0. So we're going to add 30 on both sides. And we get k squared minus 10k plus 30 is equal to 0. For quadratic formula, our a is a 1, our b is a negative 10, and our c is a 30. And we can start filling in our quadratic formula. X equals opposite of b plus or minus square root b squared minus 4ac all over 2a. Always start with the part underneath the square root. Don't use the square root symbol, but just do this calculation. 10 squared is 100 minus 4 times 30, which is 120. So we would get 10 plus or minus the square root of negative 20 all over 2. And here's where that imaginary solution comes into play. Your first step, if you want to leave this as an exact solution, is to just change it from the square root of negative 20 to making it the square root of 20 and putting an I for imaginary with it, all over 2. This is called an exact answer. We have done no rounding. If your textbook or a test ever asks you for an exact solution, this is it. Now to get a decimal form of our answer, we could use our calculator and do the square root of 20 on our calculator, which would be x equals 10 plus or minus. The square root of 20 was 4.47 imaginary, all over 2. You could leave your answer like this, or you could reduce it by dividing 10 by 2, which is 5, plus or minus, and the 4.47 divided by 2, which is 2.236, we'll round it 2.24, imaginary. This shows our two answers as well. This is called decimal form. The other one was called exact form. And there's even one more format, which is simplified exact form. So that's our last step. For simplified exact form, we go back to that old skill we did way back, where you start with the square root of 20 and you try to simplify it by making what's called a factor tree. 20 is 4 times 5, 4 is 2 times 2. So if you're thinking about square roots again, the square root of 4 is 2. That's why we have this pair of 2's at the bottom. The number we don't know the square root of is the 5. So our simplified form of this square root is 2 root 5. The square root of 20 is the exact same thing as 2 times the square root of 5. So remember, you're looking for that number that's paired at the end to come out, and that's because the square root of 4 is that 2. So to write our quadratic formula problem, going back, instead of the square root of 20, we're going to replace that square root of 20 with 2 square root 5, I all over 2. And then you're looking to reduce your fraction by 2. So we're going to do 10 divided by 2, which is 5. The square root number never gets divided. It's part of this whole term. So 2 divided by 2 is 1. Putting the 1 is completely optional. You don't need to have it. Square root of 5i. And you can put the x equals. This is simplified exact form. All three answers are the exact same thing, just different ways of writing it. In our level, we're not going to be picky about which version of the answer you write, but in Algebra 2, they will ask you to do the simplified exact form. So let's do one more quick example. This will be one that's in vertex form, which would have come from completing the square. So if we ended up with an equation that's 7x minus 5 squared equals negative 2. To undo the squared, we would need to square root both sides. Previously, we would have said this is a no solution, but not anymore. Now we're going to write 7x minus 5 is equal to the positive or negative square root of 2, and because of that negative, we just put an I to say it's an imaginary square root of 2. Then we keep solving for x. So to get the x by itself, we need to add 5 on both sides. 7x equals. The 5 is not a square root, so it doesn't go inside the square root. They're not like terms. The 5 is also not imaginary, so we just keep it separate. It's 5, and we have a positive or negative square root of 2 that's imaginary. And then lastly, to get the x by itself, we divide by 7. So our final answer is 5 plus or minus the imaginary square root of 2, all divided by 7. This is in simplest form. The square root of 2 is prime. It doesn't get reduced anymore. And 5 can't be divided by 7.